Okay, welcome back to part 2, and this is page 4 in your notes. This is from page 322 in your textbook, and you can go there, and there's 3 really good examples if you want to look them over. This example talks about mixing green dye and dark purple dye, and that's where the G and the D come in. And they have written these inequalities for you, and you're asked to graph them below on this grid. What we're going to know, though, or look at, is just the boundary lines when a dashed boundary line crosses over with a solid boundary line. Okay? On yours, I'm not sure if your notes have this answer key, but let's just have a look at this answer key for a minute. Sorry. There we go. When we graph this, you can see the solution region for this dashed equation is here. Okay, all of that. And you can see then the solution region for the solid graph is down here. Okay, and you can see the overlap. My overlap has turned green. And you can see this green area now. It has a solid line here and then a dashed boundary here. Now remember that dashed boundaries are not part of the solution, so we could not get an answer right on this dashed line. We can also not include this point where these boundaries intersect, because one of them was dashed. So then we put an open circle. It's not included in our solution. All right? If you want to do this example as practice, you can go ahead and do that on the grid provided. Let's pause it then if you want to do that, and go ahead. Otherwise, let's turn over to page 5. Here's an example with Matthew. May or may not be Matthew Porter. But Matthew's setting up his new social networking page. First bullet, he wants no more than 500 friends on his new social networking page. And second bullet, he also wants to have at least 3 school friends for every hockey friend. And no affiliation with any hockey team, except for there is a Humboldt Broncos logo on the page. So if we think about that, Matthew, if he has 1 hockey friend, then he'll have 3 school friends. If he has 2 hockey friends, he's going to have 6 school friends. If he has 4 hockey friends, he's going to have 12 school friends. Okay, so at least 3 times as many school friends as hockey friends. Let's define 2 variables here. Something that makes sense. We can see there's 2 options within the question. We have school friends and hockey friends. So let's let S equal the number of school friends and H equal the number of hockey friends. You can write that down. Okay, good. Now, second, B, we're supposed to write a system of inequalities that models the situation. Now, normally in questions like this, each inequality is given in its own bullet. So let's look at the first bullet. He wants no more than 500 friends. So together his S friends and his H friends have to be equal or less than 500. So S plus H is less than or equal to 500. Okay, the second bullet then, he also wants to have at least 3 school friends for every hockey friend. So we talked about this a little bit. If he has 1 hockey friend, he's going to have 3 school friends. And 2 hockey friends, 6 school friends. So we see that the hockey friends is always multiplied by 3 to get the school friends. Another way to look at it is, and I mentioned this before when we did that example with Mr. C and the hockey team, is to set up an equality or an equation first. So I know that if I was to make these friends equal, the school friends would equal, the school friends are 3 times as much. So in order to make them equal, I need to multiply the hockey friends by 3. And now we know that this is not an equation, it's an inequality, so let's erase the equal sign. The school friends have to be at least. They have to be more than or equal to however many hockey friends we have. Okay, so there's your two inequalities. Describe the restrictions on the domain and the range. I don't think we've done an example where that's asked us. We know that, first of all, the variable s has to be greater than or equal to 0. We know that because you can't have negative friends. And also the variable h, same thing, has to be greater than or equal to 0. Another thing we know is that s is going to be a member of whole numbers because we don't have decimals or parts of friends. They need to be a whole number, and we can also have 0 friends, so we need to include the 0. And also we know that h is a member of whole numbers. Good. D. Graph the solution to determine the two possible combinations of school and hockey friends that he could possibly have. Okay, so this is where you come into play, and you're good at this already. We've got equation 1, and, sorry, not equation, inequality 1, and then inequality 2. Let's decide to make h the horizontal axis. We'll call this h, and we'll call the vertical or the y-axis we'll call s. I just picked this, number 1, because our second inequality is already solved for s, and that's what we always want to solve for, y equals mx plus b. So it makes sense if that one is already solved, let's just leave it like that and call s the y-axis. So the first equation we can solve then for s, we'll minus h from both sides. And then we can find our m and our b. We can draw the boundary line. Both boundary lines will be solid because they're greater than or lesser than and equal. And shade the regions on both sides of those boundary lines to find where they overlap. Okay, if you want to step through it with me, then keep watching. If you would like to pause it now, do it on your own and then compare our answers. That would be great too. Okay, here's your slope and your y-intercept for each inequality. Let's label this axis. I think every 4 lines can be 100, and that will work out very perfectly. Okay, go ahead, pause here, and plot those two boundaries. So the first inequality, s is going to be less than the boundary line. So here s is less than. I'm going to shade this all in. And the second boundary line, we see that s has to be greater than the boundary line. So that's on this side of the boundary. And I'm going to shade that all in. Okay, so now our solution, the question asked us to provide 2 possible combinations of friends for Matthew's social networking page. And we know that that solution will come in the place where these 2 inequalities overlap. So any point within the overlap is a possibility for Matthew, including the boundary lines because they're solid. Okay, we could even do right here on the boundary line of 0. Now, if we wanted to provide 2, let's go with this one here. This ordered pair is 125 on the x-axis and 375 on the y-axis. Let's check to make sure we're right. Together, those are 500 friends, and that fits our inequality because the school plus the hockey friends need to be less than or equal to 500. Does the second inequality work? So the school friends are at least 3 times the hockey friends. 125 times 3 is 375, so yes, that works too. Okay, so that's one option. You would write that out in a sentence. Matthew could have 125 hockey friends and 375 school friends. Or let's pick another option. How about this one here? that ordered pair would be 25, 300. And let's see, together it's 325, so that fits or solves is a solution for the first inequality, and hockey friends are at least, school friends are at least 3 times the hockey friends. That's true as well. So the second sentence would be, Matthew could have 25 hockey friends and 300 school friends. Remember, you can pick any solution from inside this overlap as long as it's a whole number, and that will work. Okay, so your assignment, should you choose to accept it, which of course you will because you want to practice these things, page 317, and you can pick anything, any word problem except number 8, because that's the one we just did above. Okay, good luck.